That's what it. That's well. Yeah, when we get the code a little bit further along, but the 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 challenge is going to be that it's going to be, you're not actually sending a key to the pet. You're sending a switch depression. So I'm not sure what you'd send, but we can send debug information. But you can look through there, like if you can look at the beginning of the code, and let's see. Let me see if I'm up and running on. Let me see if. Okay, hold on here. YouTube.com and let's see. So where is my channel? Yeah. Yeah, here we go. So the channel is here. Let me put it in the chat. There's the and put it in our chat. There you go. And then so anyway, let me check. Yep. There we go. So in any event, and I don't know why that box is sitting right at the middle. I'm not sure what it is, isn't it? Let me see if I can figure out why it's there. I do not see why it is there, but let me, yes, I am. Yeah, but there's nothing, I mean, that's the whole, yeah, so, hey, well, it won't really affect us anyway. I think it's because that's like where the cameras say they get the notifications or whatever. But anyway, so if you look at PETKey, which is up on the screen right now, yeah, so if you look at it, you can see right here. So the key is you'll get, every time you get a key scan code, so scan C64 key _1 means that a 1 was depressed. And then I debug, I output a 1, and then you'll see that the key that it's being sent is one of 3 categories. So there's so the first category is unshifted, the second is if it's shifted, and the third one is if the control key is down. So most of the time they're the same, but a lot of times they're not. So like the 2 key, if you get a 2 on the 64 keyboard, if it's unshifted, you want to send a 2 to the pet. If it's a shifted 2, you want to send a unshifted double quote key because that's a special key, and that's what. So mod override means mod override means if the shift is down, take the shift off, right? Because if we just did a double quote by itself, then it would let the shift key continue to be pressed down because the C64 shift key would have created a PET shift key transmission. And what we need to do is we need to undo that and then send the double quote because you send an unshifted double quote on the pet. Mm-hmm. Commodore key does not currently does not. I mean, um, we can change it so it does, but you're you're not. Oh, that. Yep, yep. And yeah, yeah, I get it. I get it. But the key is you have to decide how you're going to do it, and you know, there's not a ton of keys that have not yet been mapped. So, um, like one of the ones you asked about was right. And if I look at reverse on, so reverse on and reverse off are done already when you hit control 9, right? So control 9 and control 0, those are already taken care of. So what I would suggest is go through the mappings that are already here and look at them, and then if you if you find what you're, if you find the information, then that's great. Hold on here. I'm gonna add one more thing. Audio app for capture. So okay.
Not see backslash.
Huh? Oh yeah,
Did
yeah.
you say back?
Yeah,
Yeah.
that one has not been done yet. So
Okay. I'm honestly, what I'm doing is I'm taking this keyboard, I'm looking at it, and then I'm comparing it with a keyboard that is on, not the best example here, but it's on C64club.com, and I'm just looking at
mhm,
I'm trying to look at the stamps on the side, which is kind of a bitch to do on this because it's top view.
mhm,
Trying to find a better example. I mean, I guess I could go back to the chiclet ones. Chiclet ones tend to have a better view.
mhm.
It's just they're not. It's not easy to decipher. Maybe this is a better view.
Okay.
Copy. Tend to have a better view.
Mhm.
I just kind of wish that I had a better view of a pet keyboard that is a normal keyboard, not a chiclet.
Okay.
And then we can kind of do a better comparison.
Well, that's fine. Um,
Here we go. I think I found one. This one's nice and big too.
okay.
Copy image address. There we go. Okay. Here's for you, for your benefit
Yeah.
and my benefit as well. I'll link this to you.
Okay.
Look at that. That is a beautiful, beautiful picture.
Okay. Well,
Because
let me.
that gives us everything.
Oh, that's fine. That's fine. So let me
Yeah,
put that. Well, let me copy that or let me open it
sure.
here. So we'll put it over. Come on. Let's go. Hello. Oh, it downloads. Okay, how cute. Okay.
I copy the URL, but either or. Um,
Okay, so there you go.
okay. So I'm looking at these and I'm
Mm-hmm.
just, well, obviously the 1, 2, 3, 4, 5, 6. So the controls for black, white, red, cyan, purple, green, blue, yellow.
Mm-hmm.
For a pet, that wouldn't make any sense. Because a pet, well, there are color pets or bodges of color pets, right?
Mm-hmm.
But color never really was the pet, right?
Mm-hmm.
So those are not mappable. And that is what control 1 through 8.
True, but I think you need to go about it the other way. I think what you need to do is you have to find the item on the C64 keyboard first, and then you have to go find what that one is on the PET keyboard, and then you write down that mapping, and we do that mapping, and then what you need to do is you need to take a copy of this picture and you need to put an X or a star or something over every one of them that you've mapped correctly, right?
Okay, wow,
and
that's
then
gonna
and then when you're done, you look at the whole thing and you see what's left, right? Because this actually isn't as good as the chiclet keyboard, because understand that, like R, for instance, on the chiclet keyboard, I believe,
mhm.
has okay, so hold on here. Let me look at the chiclet keyboard.
Yeah, I'm gonna look at the keyboard too.
Chiclet keyboard um,
Here's a good example. Got
for
it.
the pet. So if we look at the chiclet keyboard, which is the one I used, um, yeah. So I will, let's see, um, save
Let me
the
see if I can
image, or
you have a larger one than one I have?
I don't know. Let me see here. Let me see how bad. Let me
Ah,
see how.
Wiki Commons has a really nice size one. Yeah, this is perfect.
Okay, well, put it in the
Um,
chat and then I'll drag it
I will
over here.
definitely do that.
Okay, so,
Here we go. It's an SVG. It's sizable for any size,
okay,
which makes it a lot easier to
that's
use.
fine.
So,
So here we go. So if we look at this one, well, no, this is fine, but I kid you not, I could have swore that the chiclet keyboard had, yeah, there's a version of the chiclet keyboard that has
huh.
two sets of things on every.
Oh, I see it. I see it. Give me 1 second. I found another one. Yeah,
Okay, so,
son of a gun. Yeah, it's actually a picture off of Steve's site. So I gotta
well, anyway,
see if
so
I can. Here we go. Found it. Well, no, that's Japanese.
yeah, yeah.
That's not the one we want.
No, I thought there was one
Um,
that had, maybe it isn't, but I thought, in any event, so I guess if they don't, then that's fine, but we need to make sure that, that you've mapped all. So however many keys there are, we need to map. And um, so what you have to do is you have to go through from this side, either from the chiclet keyboard or from this keyboard. Then you need
right.
to mark off every one of them that you did, because I did all of them that I thought I could find
Sure.
on the on the C64. Now, what I did figure out is that, so um, you've got, like, look at 4, 5, 6, and star over here. So you've got little bar, bigger bar, and then you've got like a hat. This one's actually a half and half bar on the 6, and then the star is the other version of 5, I believe. And then over here somewhere is the the other version of 4, right? So let me see if I can find it. What I found is that, or maybe it's the other way around. Maybe these are like, star is the equivalent of 4 and 5 and 6, but on the Commodore keyboard, you've got um, like H, Shift H is the left, Shift H is equal to 4, and Shift J is equal to 5, and Shift K is equal to 6, and Shift L is equal to star. But there's another one, I thought. Yeah. Shift N and Shift M are, so what I saw is that there's, like, if you look at the counter keyboard, you've got G H J K L N M is the whole setup. So G is the thin
When you
line.
say Commodore keyboard, are you saying C64 or
I'm sorry,
PET?
I'm saying the C64 keyboard. If you look at
Okay.
G H J K L N M, you'll see um, like 10%, 20%, or no, let go a little bit, like 10%, 25%, 35%, 50%, and then it goes the other direction. So K is the middle of it. GHJ go up to K, and then LNM go back down to, they
I
do the
have
other
an
side.
idea.
Hmm.
I have an idea.
Yep.
Okay. So I have an idea of looking, and I could not find a double stamped entry for these pets. I looked all over.
Yep.
So I think it is one pet ski per. So it's the
Oh,
what is it?
I just found,
Shift?
yeah,
You found?
I found them. Um, so the mapping is, um, so G maps to shift percent, right? Look at G and then look at shift percent on your keyboard mapping. So if you go to, um,
Wait, hold on. Shift percent on. Oh yeah, 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 yeah. Okay, on the pets. Yes, you are
yeah,
correct.
so if you look at, so the G key, or if I get a 64 key of G and I get an actual G, then um, it would be you know like it would be just the regular G key. So I'll send out a G key. Now, if we get and these must be control. Maybe these are control characters. You hold down the control key to get these. Maybe.
I, I'm assuming so. On hold on one second. Give me 1 second. I
Well,
lost
yeah.
my window here.
Anyway.
Um.
Hmm.
Okay, so we have. Where is the control? I see shift lock, reverse on off, run stop. There is no control on the
Yeah, you're right.
keyboard here.
So there is no control.
So is reverse on off it? Is that how it's
No, reverse on
anybody?
off is no. That's does the same thing that does on the 64.
Oh shit. Okay. Anybody who's listening, how in the hell do you get to the Petsky?
Yeah, it might be shift. It might be just like A, and then shift
Oh, okay.
A
Yeah, there's
is
no lowercase characters. You're right. There's no lowercase
exactly.
characters in the pets.
So in any event,
That's right.
so we have a challenge here, right? Because the one is, um, so the G key on the on the on the pet is equivalent to the, um, let's look at it over here somewhere. It's like the B, or yeah, the B, control B is equivalent to the G, uh, with the line a little ways over from the left hand side. And so the key is you're going to have to figure out, because on when you do a mapping for G, like you could do G and shift G, which would be, whatever the uppercase G it turns out to be, or like that would be one option, and maybe that's best for the business keyboard. And then for the non-business keyboard, maybe what you want it to do, because shift G on the 64 is equal to the shift percent um, on the non-business keyboard.
So I just linked you that link.
Hmm.
When you say business keyboard, you mean this keyboard, this pet keyboard?
Well, no, this is actually, the business keyboard didn't have, I don't think it had the graphics characters on it. So
Oh, okay. So we're talking about the smooth looking keyboard. Yeah, I know which one you're talking about. Okay, so yeah, I sent you a link and explains why the pets. Yeah, because shifts is your pet ski. So that makes perfect sense. So okay, so what I'm going to do is I'm going to take that graphic and I'm
mhm,
going to put it into my graphic editor
mhm,
and I'm going to overlay the actual key that it corresponds to
mhm.
on the Commodore 64. So that is going to probably be the easiest way for us to just kind of, um, well, I'll do it. I'll do something. I'll do something. At least mark them off as plotted because then I can just do it in Notepad either or. So I'll do that right now. Open some Notepad plus plus and goodness gracious. But yeah, we're gonna have to use the Commodore key in your
Well,
case.
maybe.
And
I mean, I, I
well,
don't I don't know whether you will or not because
oh yeah, we got to find out if. Well, here's the thing. Look at Q. Q is a good example here. Notice the Q. Um,
yeah, Q and
because Control is the first one. If you look at the Commodore 64 keyboard, it is the kind of a T sideways
yep.
shaped,
Hmm.
and then the Commodore key is the circle. So you're going to have to use Commodore key for the translation.
Um, well, yeah, you might. Yeah, that's true. You will because a
Yeah,
Commodore key on the so Commodore, if you well, or you
yeah.
can use the Control key actually. I think.
No, Control key is the first one. It's the
No,
so
no,
looking at the
no. If you
C64.
yeah, but if you do it like I have my 64 up here right now. I type
Okay,
Q,
you do.
and if you do Shift Q, see the
Hold on.
the on the Commodore 64, the shifted item is the item on the right side of the key cap. So a
So it's the shifted.
Shift Q on the 64 is a filled in circle.
Wait, Shift Q. Then what's the Commodore Q do?
Well, Commodore Q makes the makes the sideways T.
Do that quickly, just for poops and ha-has.
I did.
Okay, so okay, yeah, I know. I'm. It's delayed. Okay, so I see that now.
So
So it's Commodore Key is the first character, and then the second character is just the shift because again, shift. Okay, so okay, so they're building upon what they had for the pets. Okay, this is gonna make life a little easier. I'm so sorry. I whiffed it. I was opposite of what I wanted to say. Okay, so
So you see here on the G, when you get a G, you send a G, and when you get a Shift G, you send a Shift G. And the Shift G on the 64 would be a filled in circle, and the Shift G on the, come on, um, there it is, on the, or I'm sorry, not a G, Q, sorry. If you
Rick
yeah,
do it,
Q. There we
Falcons.
go. Yeah.
Shift plus plus on pet.
So Shift Q should match Shift Q is
that's right,
on the
Shift
pet.
Q
Yeah.
and Shift W does as well. All of them
Okay.
actually, ERT, Y, U, I, O, and P all match exactly. The
Well, I
so
got a question here from Rick. Shift plus is not correct. You are absolutely correct. Shift plus is the
well,
Commodore
so
key.
yep. So if you look at where
You
we have Shift plus, so what I've got mapped right now is if you get a, let's get rid of this. If you have a plus on the um, 64 keyboard, if it's unshifted, you send a plus um, on the PET keyboard, which would be over on the right hand side here, down next to the 3. And if you have a shift plus on the 64, then what you have to do is you have to do a virtual unshift, which is what mod override does, and then you have to send a left bracket key because shift plus on shift plus is um, see, you look at the graphic on.
yeah, look at the pets. The pet keyboard has that sideways T like on the Q on the Commodore 64.
Okay, so I have it mapped wrong. I wonder
Yeah.
why I had the bracket. Well, anyway, so then you're right. What it needs to be then is it needs to be sh- shift. Uh, let's see. No, a shift plus on the 64 needs to be, yeah, it needs to be a shift. it needs to be a shift left bracket on the on the um, uh, on the PET.
Shift left brackets.
Yep.
Hold on here. Shift left bracket.
Yep.
1 second. On the pets.
Yep.
Left
But
bracket.
it doesn't need the override, so I can leave the override off.
Where's the left bracket?
It's up at the top right
Um,
corner of the
oh
keyboard
yeah.
part.
Okay,
See?
so yeah, that's the plus sign. So that shift left bracket is the plus sign for uh
It's a shifted
for the yeah, the shifted
right.
plus.
Right. So that's how
But
you hmm?
here's the thing though.
Yep.
Look at the pet keyboard and look at the plus right there.
Yep.
See that plus? Okay,
Yep.
the plus is that sideways T,
Yep.
which is the Commodore Shift Q. I'm the Commodore Q.
That's right. So then what you have to do is you have to work it backwards. You have to say you always work it from the 64 keyboard to the other one. So what we do is we say, okay, um,
Commodore
the
Q
Commodore
equals
the Commodore Q equals. So what we do
Shift
is we
plus.
go up to the Q key.
Rick Balkans. C equals plus Q on C64 should equal Shift plus plus on PET for corresponding symbol.
Yes, that's exactly correct. So that's what this mapping is. So if we look here and we do Q, UA, G, where is Q? There it is. So Q, and you do a Shift Q, then when you do, I guess it's the Commodore key is what these are. So that's what it is. So if you have the Commodore key and you press the plus on the 64 keyboard, what needs to get sent to the PET is the well, what I have here
Shift plus.
is the shift plus and an override, which I think
Okay,
is right, right? It's a shift plus
hold
and
on one
yeah, it's
second.
a shift plus.
Okay, so let me go look for the function here. Control C,
Mm-hmm,
find previous.
mm-hmm.
Okay, void here. Okay, I'm just looking at set V key. So I got unshifted, shifted, control.
Actually, it's Commodore. It's Commodore. So it's shifted, unshifted, and Commodore. So
Okay, well I see control.
I was using the Commodore key because I thought there was a control key on the PET, but there's not.
Oh, okay. So what's the control key do then?
The control key, when you press the control key, so down here there's a special set of code for the control key right here.
Okay,
So when you press the control key, it says, I'm going to record that the control key has been depressed. So is um, state is a variable that comes into the function that tells whether the key is being pressed down or let up. And
okay.
if it's true, then that means the key is being depressed. And
Right.
if that's true, we set this meta flag, which is a global flag, to say the meta key control is depressed.
But
And
I mean, what
so,
does control do on the Commodore 64?
well, the control doesn't do anything. It's a meta key on the 64.
Okay.
I
Oh,
mean,
so it's used in other applications.
it's used like shift. It's the same kind of
Okay.
idea. Control, shift, and Commodore key are all used the same way. They're individual
Right.
keys, but they don't do anything on their own, at least in the normal. Um,
So control is just not a function on the Commodore keyboard, anything specific, but programs can utilize the control key, is what you're saying.
yeah, and actually, I got this. I used the control key to do this work, but it's the wrong thing. I should use the Commodore key because I didn't realize all those things are the Commodore, not the control. So we'll
Right.
change
So
this.
you're gonna have to change your
So,
function as well.
well, no, the function doesn't matter. It just looks at the
Okay.
state of this flag here, right? So,
Okay.
but I mean, I'll change the name of it. So we'll change the name here just because it's, just to keep things right.
Right.
But okay, Meta
So
Commodore. So anyway, so what it's going to do is when you hit the CBM key, it is going to
uh-huh.
yada 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 yada. Okay. whatever. Not sure what all it's doing here, but I'm going to just bring this over to the side. So that's all taken care of. And then what's going on in this one is the control key. So we'll change it here because the control key, we're going to deal with it later because I'm not sure exactly what we're going to do. But right now, if you hit the CBM key, it'll print out CBM at the it'll print out CBM on the serial console, and it will set this meta flag called Commodore. And then, so let's say the user on the 64 is holding down the Commodore key, and then they turn around and they hit, let's see, the key that we were thinking about was Q, right?
It was the Q.
That's right.
So Commodore
That's right.
Q,
So Commodore Q makes the sideways. It makes the sideways
a
T,
T.
right?
Yeah.
Okay. So on
Yeah.
the PET, that is equivalent to typing Shift plus.
Okay.
So that's what this means.
So give me that code so I can compile it and test.
You have it.
Just, huh?
You have it. You're in it.
Oh no. Okay. No. What I'm saying is you just made those changes. If you just
Oh
copy
yeah.
that code,
That's true. Yeah. Well, I
yeah,
hold on here a second.
yeah, that's fine.
So okay. Okay. So fix mapping for Commodore key. Whoops. There you go.
Okay. So I'm going to refresh the. It's like, which is it? It's the pets. Let me find it. Source.
So.
Pet VKB Pet C. Okay.
Mm-hmm.
And 15 seconds ago. So that commit is now live.
Correct.
Okay, let's get the raw. I'm trying to do control copy on the Commodore 64 keyboard. That's not going to work right. And then let me go into here, and then V. Okay. Okay, I'm not seeing your changes saved.
Well, if I did it
Did you
15
not save?
seconds ago. Huh? Oh, you know
Weird.
what? You're right. Sorry. Okay.
You committed.
I committed. Well, I committed some changes, but I didn't.
Yeah.
I didn't
Oops.
commit the changes that you needed. So here, let's fix that. PETKey.
It's okay.
Here we go.
Okay. Let me refresh that again.
Okay. Hold on. I gotta make the change here. So
Sure.
more changes to mappings. Okay. There you go.
Your Facebook's gonna be lit with all these changes.
Okay. So there you go.
Okay, refreshed 20 seconds ago. Woohoo. Okay, good. Okay, so now let me go to raw. Control find CBM. Okay. Weird. I thought you created new keys for CBM in VKB underscore pets.
Create.
Oh yeah, control. Okay, I see control here. Meta control, meta shift. Go back to what you did previously.
Right here. It's on line
Those lines.
417.
417. Give me 1 second.
Mm-hmm.
Scan C64 key control debug puts control. Yeah, I don't have that. It seems like my version. Let me refresh. Hold on. Control.
Okay, well,
Why is it
we can take a
not?
look here.
Okay, so I'm going to refresh it again. And looking at 417. Okay, this one is, you said 417 CBM states. Okay, on here it's correct. Why is it caching? Let me just go back to raw. All copy. Let's
Yep.
go back to mine.
I was going to say it's there.
417. Yeah, son of a, why? You know, I'll just copy it off of here then. You're gonna be a dirt computer, and the raw is not correct. I'm just gonna copy it from here.
Yeah, I don't know.
Some weird caching is going on. There we go. Goodness gracious. Upload. Okay, thank you too. Okay, so now clear input, CBM, control. Yep, they're working correctly now. Okay. Run, stop, run, stop. Okay. Dandy. Okay, good. So now I'm going to go and okay. So right now all we're doing is testing what you, I mean not testing, but looking at what you did on the mapping and verify is pretty much all we're doing right now, right?
Well, what I want to get to is mapping the what I want to get to is mapping the pet, do the pet mappings, right?
Okay.
So the pet mappings are already set up. We just have to get them configured correctly. So the first thing
How okay, yeah. So I mean, how would we go about doing that? You said first thing, I apologize. Go on.
so right here we have the circuit, which is,
Yep.
so this is the MT8812. So we know that AX0, 1, 2, and 3 are on some specific lines. AX0, let's see, yep, 0, and then there's a AX1 is on pin 20 and whatnot. So then what we got to do is we have to bring up a schematic of the Mega 2560 pinout. And
While you do that, I'll be right back.
mm-hmm.
I'm gonna step away for 1 second, take a bio break.
Okay. All right. Here we go. Okay. So BC1, BC, that must be in the Vic column, Vic row. Okay, so that's fine. Reset is pin is 1, 2, 3, 4, 5, 6. Reset is pin 6, and pin 6 is 1, 2, 3, 4, 5, 6, which is PC6. PC6 is reset. So, whoops. Here we go. PC6. So we need to go to here. Okay.
I am back.
Okay. So I figured out that the reset on the crosspoint switch is pins PC6. So we just need to HPT underscore reset underscore pin is pin 6. Actually, let's see. Yep. Okay. And then, so that takes care of reset. So what we'll do in that is we'll do some stuff in here. So in the keyboard code, let's see, right here, we'll do a little bit of, actually, XPT underscore net. So we'll have to say this is or equals pin. That will set the pin to output. And then, let's see. And then we will, oops. I think if we look at the, let me look here and see the reference manual for that chip is right here. So let's look at the reference manual and 5th page. So it says reset active high. So that means we can just bring it high, wait a second, and bring it low. Let's see what it says about reset. It needs TRPW. So TRPW is 40 nanoseconds. Oh, well, that's pretty easy. So what we'll do is we bring the port to be an output. We'll set it high, and then we'll do a delay I think it's underscore delay underscore microseconds 1, and then we'll set the reset to be 0 again.
Now that delay function, just
Oops.
curiosity here, it doesn't pause the whole Arduino. It just delays that part of the code.
No, it actually delays the entire Arduino. It essentially stops the CPU for 1 microsecond.
So what if, say, for instance, somebody else is typing something else?
Well, you're only 1 microsecond, so you're not actually scanning anything while you're doing that, and you only scan 60 times a second. So, and besides, this is something you only do at the beginning of the. You only initialize the the matrix once,
Okay.
right?
I just, delay is,
Yeah. You're right. You're right. But the other option is to set up an interrupt and then wait for 1 microsecond, but it's a 16 megahertz chip, and so you're only waiting 16 instructions. By the time you issue the interrupt and get in the interrupt handler, save the registers off, change the value of this, and then get out of the interrupt, you're going to have spent at least 8 or 9, probably more, probably by like 10 or 11 cycles, which would be almost a microsecond.
Yeah.
Okay, so we're taking care of. So we've reset the system. So we took care of that. Now, let's see, we don't need this right at the moment. What we do need is to see the next thing we need to find is AX0, 1, 2, and 3. So AX0 is pin 1, 2, 3, 4, 5, 6, 7. 7. And so we have pin 7. 1, 2, 3, 4, 5, 6, 7 is PC4. So PC4 is AX0. So then we have to go back to the code and we have to say define XPT is DDRC and the port is port C and the other one is, what did I say it was, pin 4? C4, PC4, I think is what I said. So we can check here real quick. So yeah, PC4, right. So AX0 is PC4. And then we just have to keep walking down that list here. So AX1, AX1 is right here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's pin 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be P. This is a crappy version of this. I think that's a PG0. Let me see if I can find a better version of this. See if we can find a better version, one that's, no, that doesn't help me. Here we go. This one's pretty good. Okay, well, of course it's not there. Oh, here we go. What? Okay. So, and I can't see the bottom of this. Why can't I see the bottom? Okay. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. PG0. So then we go back to our code and we say this is DDRG, port G, and it's pin 0. So, and we'll just do this again for AX2 and AX3. Whoops. So 2, let's look at 2 here. So AX2 is 1, 2, 3, 6, 7, 8, 9. So it's pin 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's PG2. Whoops. So PG2. And then AX3 is over on the other side here. It's 1, 2, 3, 4, 5, 6, 7 on that side. 1, 2, 3, 4, 5, 6, 7, which is PC3. Okay, so that defines all of that. And now we need to define y, actually, you know what? I'll do it this way, it's easier. We need to find the y-axis on the switch matrix, which is a y, 0, 1, and 2. Okay, so then let's look at y. So AY0 is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9. 1, 2, 3, 4, 5, 6, 7, 8. Right? Yep, 9. PD7. So PD7. Okay. And then Y is over here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. PC0. PC0, that's fine. And then AY2 is, there it is right there. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, and that's PC5. Okay. So let's see what we got left here. So we've defined AX and AY. We've defined the reset. We need 2 more lines, data and strobe. So, okay, define SPT underscore data. Actually,
What did you call those special characters like shift and control and
meta
Commodore? PETKey.
keys.
Thank you.
Mm-hmm. Okay, now.
So I'm
Hmm?
I'm right now in Excel
Yep.
doing the mappings, so it's
Yep.
you make it a little easier.
3, 4, 5, 6, 7, 8. So it's pin 8. 1, 2, 3, 4, 5, 6, 7, 8. PC1. So it's PC1. And then we need one more here, which is strobe. Strobe is, there it is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which would be PG1. Okay, there we go. So we've defined everything. Now, what we should do here is don't need these anymore. And then we're going to have to now what we're going to have to do is we're going to have to define some static.
You know what? I'm not going to do this in Excel. I'm going to do this in Sheets. It'll be easier.
Okay.
Drive. This way I can share it. Sheets.
Okay. Hmm. Okay, so we've got DDR right here. Ooh.
Shift C, Shift out. Yeah, that's correct. And then
Got this one. This is strobe. Okay. So in the world. Oh wow, I forgot. That's what that little black box was there. My screen. Now I know.
okay, that's right. Okay.
Okay. So we need to let's see. We need to set me see if matrix is, or let's look at this strobe line. Strobe line is active high, which is good. So we just need to make sure it's set to low here.
Let's see.
Okay. So
Okay. Is a shift.
okay, now we got one more function we need to define here. Static. Let's see. Set switch.
CPM.
Row. Meant 8 column. Data. Okay, so let's see here. So xpt underscore ax0 underscore out is going to be or equals, let's do it this way, if row and 1 underscore pv okay, oops, else four, two, 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 and then and 8, 3, 3, 3, 3. Okay. Okay, if column and 1, a y0, okay, that's data. And so if data, then data. Otherwise, there we go. Now we just have to strobe and unstrobe. So
Shift 7.
okay, so that takes care of everything we need to do. Oh, okay. You know what? We need to put this up at the top. XPT send. Okay. So now what we need to do is under set switch, we just say XPT underscore send. And it'd be switch. I wonder what switch is. Oh, switch is the switch. Shifted and mod override. So control and mod override. There's the left shift key. Oh. So don't need this.
I linked the key mappings that I'm working on right now.
Mm-hmm.
Oh, this is a bear.
It is. I agree. Okay.
And some of these are just assumptions. I might be wrong on some of these, especially the ones that are like, box filled in barely versus box filled in quarter way versus the halfway. I can tell, but
You'll
the
have
quarter
to,
way
I
one.
mean, the only thing you can do though is try something and then,
Right.
I mean, it's not like.
Come back. If I'm wrong, then come back to it later. Yeah.
Mm-hmm.
Fun times.
Mm-hmm. Okay, so
What did my mom always say? You brought this onto yourself, Chris.
Fair enough. Okay, so
Oh, let's see. 19.
okay, so let's just make a note here. Bits are 0, AY, 2, 1, 0, comma, AX, whoops, 3, 0. Okay. And then we're going to have to include slash delay dot h. All right.
Yeah, I'm in this keyboard mapping. I'm going to map out pound and put backslash on that one, and we'll deal with that later.
Util delay. Okay, let's do a little code here. Okay, strobe out. Oh, how cute. XPT strobe.
Here, Rick, I'll give you the link that I'm working on right now.
Oh.
It's slow going. But there you go. There's the link. Watch me edit it live. Let's see. Okay. Half checker. So CBM minus shift.
Okay. Oh man, what is fine? Util dash delay dot h avr. What's the convenience function? Oh, underscore delay underscore US. That's what I used. Oh. Row undeclared. Switch. Okay.
The PET keyboard I'm using is it's the same thing. I'm using right now the one that was on Jim's screen because it had the most detail. But looking at the chiclet version versus this one, they're one and the same.
Well, we're close. Let's see. Undeclared. Oh. XPT underscore net. Ta-da! Okay. So we've got a clean compile.
Okay.
Now we've got to do these mappings, which are going to be kind of complicated. In fact, they're going to be really complicated.
What time do you have to wake up tomorrow?
It's Saturday.
Well, your alarm said 7:30, but I mean, I doubt
you can't
you
set
want to
it.
wake up at 7:30.
Yeah, I don't think you can set that for weekdays, so or just
Oh,
weekdays. I think it's just a everyday thing. Okay, so we've gotten all of the cross-point switch mapped. So now all we have to do is do the actual mappings for the cross-point switch, which we'll get maybe a couple of them here. Okay, so now let's bring up PETKeyboard.h and let's see. Okay. So when I made this, I said 0, 0 was the top left of the, let's see what we got here. So pet keyboard matrix. Is this it? Let's see. Cursor right, or no, ampersand. Equals. Nope, equals have the, where's equals? Okay, so right there. 0, 0, and then period right there. Okay.
let's see.
This is the one that's going to be even more complicated. Oh. But the good news is once we do this one mapping, we're done. So 0, 1, 2, 3, 4. Interesting. Verse. So PETKey equals 0, 0, 0, 1, 0, 2. Boom, boom. It's not 0. So, oh, none. There it is. Okay. And this is 0, 7, I think. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. 3, 5, 6, 7. Yep. Okay. Now we have to define what 0 is from a row perspective. So the row is here. You have to look at the setup here. So PR0 to PR9. So PR9 is 0. And PR9 is X11. So X11.
That's probably
Be
shift colon. And this would be shift semicolon. And then this is straight bar up down. Okay, so that's minus.
so pin 1. Now we have to look at the mapping here. PET keyboard connector. Okay, here we go. So row 9 is, okay, so key 10. So we need to copy this right to our code here. Oops. Let's do it this way. Oh, shoot. Okay. So first few pins, we're going to take a look at pins here. So PR9 goes, okay, so PR9 is, okay, PR9.
First row is done.
Yay.
I need to take a break. that was a bear. Yeah, first row is done.
Good. Good deal.
And I don't think it's 100%, but it's somewhere.
All right. Well, that's fine. Okay. Okay, so X 0. I want to do this. Okay. So Y, we know Y needs to be bit 4, 5, and 6.
Question about reverse on, reverse off.
Yeah.
Is that a clicky button, kind of like how Commodore 64 is shift lock?
Nope. No, because there's 2 different keys for reverse on and reverse off, right?
Well, on the Commodore, yeah. I mean, on the C64, but not the PET keyboard.
Well, no, I think it is on the PET too, right? There's reverse off right over here.
Yeah, there's no reverse on though.
Oh, well, I'm pretty sure that's not a. Pretty sure that is not a thing. So I'm trying to figure out
A
where.
latchable
I
key.
don't think that's a
Yeah.
latchable key. Because they didn't change this. They didn't change this keyboard very much to create the VIC keyboard. The VIC keyboard is just this keyboard with the clear home and the cursor row, or these columns, and the insert delete columns removed, and the function keys, or maybe it's this set of keys. I think it's this set of keys that are kept, and the other 3 columns are just removed. And so that's how they made the first VIC keyboard.
So, how we would control reverse on and off? Pressing it down would be on, but
I assume that no, what this means here is, so you're reading it. Yeah, I think you're reading it wrong. So Let's see. How do you? Yeah. So um, look at insert and delete, right?
Mm-hmm.
Now look at off and reverse. So what this means is if you hit the key, that means turn reverse on. If you hold down shift and hit the key, that means turn reverse off.
Okay, so okay. Shift.
Okay. So
Okay.
okay, so
Okay. Got it.
mhm.
Oh.
Whoops. Okay. 16, 32, and 64. Okay. All right. And these will be 4 and 8. Okay. Now 0, 0 means the column is X is going to be Okay, so the hmm, getting it figured out.
Yeah, I'm now halfway done with the second row. I'm just kind of looking and trying to find PETKey. There we go. C and V.
Okay,
C
good. Oh, awesome.
CBM.
Do you see that Rick sent
C.
something here?
Oh,
It's like a
are
PDF
you
file.
kidding me? Did he just?
It's got a manual.
Yeah, look at the reverse off key. Okay. Yep. Let me take a looky, Lou. Okay. Page 21. Looking now.
Okay,
Okay.
so we need. So PR9 is on X11, and so X11 needs to be row 11. Or no, this is the really
Yep.
bizarre part of this chip.
Yep.
Gotta love it.
The directions that you gave are absolutely correct. So if you do
Mm-hmm.
reverse off, it will do reverse, and then you do shift reverse off, it'll go back normal. Okay, so good news.
Okay, so now you need to help me because I need help.
Okay, what do you help with?
Well, so we've got this is the big mapping um, for the crosspoint switch. So there's there's like a 3 or 4 level mapping here that we have to go figure out real quick. Once we figured it out, then we'll be done.
Oh, by
So
the way, thanks, Rick. I appreciate it.
um,
Sure.
so we have, if we bring it up Excel here, let me get Excel. So here's the challenge. We have a keyboard pin, and the keyboard pin maps to a crosspoint pin, and the crosspoint pin maps to a crosspoint value, and the crosspoint value is, so I think that's that's okay. So we've got a keyboard logical pin, and then we've got a keyboard physical pin that maps to a crosspoint pin that maps to a crosspoint value. So this is the challenge. So right here, huh?
Okay, yeah, I'm good.
Okay. So so what we've got is if we look at this, let's see, let's go to here. So we have on the PET keyboard, we have 10 rows and 8 columns. 10 rows and 8 columns. And then we know that, row 9 hooks to PR9 and so forth. So PR9, and then we've got to look at this picture here, which is, I think it's this one right here. So if we look at this keyboard matrix, you've got pins, physical pins, and let me bring up my thing here and make it smaller. Okay, so probably we'll need some help here. So we've got the keyboard pins and the logical pins is right here. So the keyboard logical, let's see, let's move this over so it's easier to, so we've got a keyboard pin, and the keyboard pin starts out on, so if we look here, the keyboard pins are the following. So pin 1 is ground. So keyboard pin 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, whoops, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, I believe, are the pins we have. Yep. So the keyboard, and we need to add a new, so this is the keyboard label. So according to Steve Gray's function or page, pin 1 is ground, which we don't really care about, and pin 2 is a key, and then we've got R7 all the way down to or R9 all the way down to R4, R3, R2, R1. And then pin 12 is, see, now I'm off by 1. Oh, I didn't get R0. And then we've got column 7, column 6, column 5, column 4, column 3, column 2, column 1, column 0. So that's the mappings. Now, the logical pin mappings that are, and so on our, let's add another one here. So this on the matrix label, if we look at this thing right here, the pins are numbered from 10 to 1, and they're labeled from H to A. So if we add, no, I don't want you. So the matrix label is, there's nothing there. Whoops. Nothing there, nothing there. And then R9 is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then C7, I'm not sure if C7 is H or A. It's a big question. So I'm assuming that it would be H, G, F, E, D, C, B, A. That would be my theory. What do you think? Does that sound like a reasonable theory?
That sounds reasonable, man.
Okay. So now we have to see. So I guess we don't need this because I've already gotten this. It's the keyboard label over there, so we don't need this one. But now we need to know what pin they are on the crosspoint switch. So we have to go over here to the system here, and we have to say, okay, so PR9 is on X11. So PR9 is X11, and then PR8 is X10. PR7 is X9. PR6 is X8. PR5 is X7. PR4 is, oh, looky there, we can just do it this way. PR4 is X6. Here's where it gets nasty. PR3 is on X4. PR2 is on X3. PR1 is on X2. And this one's on X1, and there's nothing on X0. And then for the columns, we've got PC7 is on Y6. PC6 is on Y4. PC5 is on Y7. And then PC4 is on Y5. Whoops. PC3 is Y0. PC2 is, whoops. PC2 is Y1. PC1 is Y2. And PC0 is Y3. Okay, so then here's the real tricky part. When you go to the, you would think that you would just set the registers to be, there'd be no problem with that. However, on the MT8812, they have 4 bits for the row, and they only have 12 rows. So instead of just making X0 be row 0 and X1 be row 1 and so forth, they do that all the way up until X5, and then X6, as you see right here, is actually 8. Is 8. So if you do an X0, then if you do an X0 through X5, then the number that you need to send on the bus is 0 through 5. So for these, so this one would be 1, 2, 3, 4, and then 6 though is different. X6 is 8. X6 is 8. 8, 9, 10, 11, 12, 13, I think. And then the columns, I think, are all no big deal. Yep. So these are 0, 1, 2, 3, 4, 7, 5, and 6. Okay. So if we use that, and then we look at our thing here, I decided that pin 10 was going to be logical pin 0. So now I have to add logical pin, logical row, and logical column. So this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so now we've got the real problem, which is on if I get a 0 here as an x coordinate, then I need to, where is it? If I get an x for a coordinate for a row, what I really need to send is a 13. If I get a 1, I need to send a 12. If I get a 2, I need to send an 11. 10, 9, 8. 10, 9. Oops, you know what? Let's do it this way. And if I get a 6, I need to send a 4. Send a 7, I need to send a 3, a 2, and a 1. Now on the Y, if I get a, so if I get a logical column of 0, I need to send a 6. Oops. So need to send a 6, a 4, 7, 5, 5, 0, 1, 2, 3. 0, 1, 2, 3. And then those have to be shifted up accordingly. So, okay, I think this is mapped correctly. And excuse me, if it is, then we should be able to compile it, and I'll stuff it up there, and then you should be able to
Take it to my pet and try it.
yeah, here I gotta save it first.
6 the opposite.
Oh, yep, it's dying a horrible death. Look at all that. Oh yeah, we got big problems, of course.
In little China.
What's the first problem we have? Okay. Matrix map. Error, invalid digit 8 and octal constant. Oh. I was too good for I was too cute for my own britches there. Okay. Let's see if this works. Yep, look at that. Okay. So I'm gonna put this code up there, and
Okay.
let's see if I've got the mapping right. And yeah, I don't know if I do or not, but we will see. Okay. So projects. Okay. Initial pet matrix mapping. Here you go. Okay, there you go.
Okay. And I just finished row 3.
Okay.
So I might as well stop right here for the moment. There. You can take a look at that while I flash this and take it over to. All right, let's see. Rick is saying I got a couple errors.
Mm-hmm. Right.
and I'll look at those in a minute. Thank you for looking it over. I'm getting sleepy. It's almost 3. So let me go. Which files did you update?
Oh, I updated quite a few.
I will just go grab the new package. That's
Okay.
fine. Um, okay. PETKey code
Shift
6.
so Shift C on the VIC keyboard is Shift C is Shift ampersand on the PET keyboard.
Browse. This is gonna go to documents. Yeah, I mean, if we look at the chiclet one, it might be a little bit easier to look at the mapping, but I'm just going based on this keyboard. This keyboard is
True, but
old.
Shift C is a line, right?
Yeah, it's just one. Yeah.
And then but Shift
So all
oh,
of
you're right.
the
Yeah.
bottom rows, yeah,
Mhm.
the letters themselves match 1 to 1. So
Yep.
Z through M
Mhm.
all match 1 to 1 on your shifts and not.
Mhm.
Um, that's the good news.
Mhm.
I've not caught a letter yet that hasn't worked with the shift correctly. Documents or Arduino. Select folder.
Fair enough.
Extract. Replace all files in destination. Okay. And then Arduino IDE. Row 4. Yeah, no, row 4. Okay. Oh, so you're saying you already have the mapping. You just did it for me. Oh, you know what, Rick? Give me your email address. I'll add you to this doc sharing so you can do it. And then I've got this. Just make sure that everything's kosher in here.
It's fine.
3, 4. Yep, that's correct. Okay, verify. Just going to quickly verify. It's good. And then I'm going to send it. Okay. Okay, it claims it's good. So let me go to the serial monitor. Okay. We're kosher on that.
Okay.
So I can now
Now you got to plug
go
it
and
in.
yeah, I got to go take it to my machine in the other room.
Oh, you have another room? Okay.
I got
Well,
plenty of room. It's a house in Texas.
true. Well, the challenge though is how are you going to power it when you take it to the other room?
Oh, I've got a power. It's powered. Oh, you're talking the board itself?
Yeah, the
I
Arduino.
thought the board is. I thought that was automatically. Oh, so I have to have this in the USB power all the time?
Well, yeah, because there's no power on the keyboard port on the PET. 64 has a power pin, but the PET does not. So maybe right
I'll
now is a good time to maybe
bring that in here.
well, yeah, I'm gonna stop and then maybe pick it up tomorrow.
Yeah, it's probably a good idea.
Because the next step is to um, is to test it with the PET and see whether we've got because I won't know until we start typing some keys to see once we get a key to work, then I can figure out, I mean, either it's right or it's
Right.
completely off. But the only way where it's off um, is to actually try it out and see. So
And I'll need to hook up my I need to hook up the thing so I can actually look at that through the monitor here. I got to clean up this desk then.
mhm.
What time is good for you tomorrow?
Oh, sometime in the evening. So
Well, what time zone are you in?
same as you.
Okay, you're central. Okay,
Yeah.
that's fine.
So I'm around,
So I'm going to
sometime
share.
around 10 or 11 or so is fine.
10 o'clock sounds like a good time.
Okay.
Editor, send.
Anyway.
Okay, Rick, you do have access. If you want to walk around and play with these mappings a bit, that's fine with me, man. I'm exhausted. I've been up for 20 hours, so it's time to sleep. Yeah, I will go and try this tomorrow afternoon,
Hmm.
at least to see if it does anything, and then see if any keys map. If the keys map, then we'll figure it out. How are we going to power this after the fact, though?
Well, it'll have to, I mean, it'll have to have some sort of like I mean, the final unit won't include an Arduino, right? It'll be a purpose-built
Right,
board. But yeah, it'll have to have power from somewhere. So, if you're using it with a mini pet, then you'll have to, put a little pigtails or something and
right,
get them from somewhere like one of the chips or whatever. Ground is already there, so you only need one line. You'll need just 5 volts, but you'll have to do that. If Yeah, I guess either way, you're gonna have to do that because you
okay.
don't really have any other options.
Well, I mean, we're still developing the other boards. It's not like a huge deal, but whatever.
Yeah, I
I'm
mean, right
exhausted.
now it's no big deal because the Arduino is just being used as a test bed. But yeah, the final board will
Right.
have to have a pigtail.
Right. Or yeah, I mean, we just have to draw 5 volts from somewhere, and I mean, hell, we can get that from the cassette or wherever. It doesn't matter.
Right.
Um, cool. Okay, well, I'll let you go. Have a wonderful night. I appreciate it, and hopefully tomorrow we have a working unit.
Okay. Talk to you later.
Have a nice night, man.